All right, the time now is 3 p.m. Can anyone hear me before we start?
Can hear you, sir.
Yes,
Right,
sir.
right. Okay, thank you. Thank you for the response. You are seeing my screen also, right?
Yeah.
All right. So just take like 30 seconds to scan your attendance and then we shall begin our session today. All right. All right. Let's begin our class today. Hello, everyone. How is everyone here doing? Are you doing okay still, wherever you are? How's it going on? Just anyone.
We're doing good, sir.
Doing good, sir. Thank you for asking.
Right, right, right. So far, anyone is anyone facing any kind of difficulty?
Not yet.
Not yet.
Everything is okay, sir.
Everything is okay. All right, all right. Just to check, because I want to make sure that every time that we have our class, I want to make sure that all my students actually are in good, mental state. Nothing is like bothering you, or nothing is like, trying to get your attention away. Because I realized that during this pandemic, we are all facing a hard time on our own, but most of the time we don't like to share our problems, especially guys. So I really would like to reach out to every one of you as students in my class. Yes, I'm your class teacher. No, that is true. But if you're facing any kind of problem that is not related to class, also, if I am in a position to help, I want to make it clear that I will try my best to help you out with it. All right. So some of you have messaged me saying that your device is not like doing well, and then you cannot access the lectures or attendance with your device. Do let me know if you have this kind of problem, even though it's not directly related to class. I will try to think of a solution, or I'll try my best. I cannot promise anyone a solution, but I'll try my best to think about how best we can accommodate you and how best to solve your problem. All right. So anything you guys want my help on anything, just let me know. Okay. Don't be shy. Just drop me a message or something if you think you're not so you don't like to like talk face to face. All right. So just to make clear on that. So I guess everyone has already signed your attendance, right? Okay. So today, you know what? I realized that this week we have a holiday on Thursday. So to those of you who are like overseas, on this Thursday, 16th of September, is actually a public holiday here in Malaysia. And on Thursday also, we are scheduled to have our 2-hour class. And I was like, oh my God, like that means that we only have we have only one class today. And because of that, we might need to reschedule our class. So what do you guys think? Do you want to reschedule the class to another day where we can have this kind of session again, like me talking and then you listening over there? Or do you guys prefer that I post a video instead and you guys can watch, and then the next class we can discuss about it? So do let me know in the chat, and maybe I'll post a poll or something. I want to know what can be the best way for this, right? Because otherwise, we might be a little bit pressed for time to finish our topic this week. All right. Anyone want to say anything about that? Do you guys prefer like this live session where I show everything like this, or do you guys prefer to watch like videos instead? Anyone feedback?
If you want to reschedule, sir, it will depend on everyone's timetable. So
All right.
I'm not sure yet. I'm okay with either.
I see. I see. Yes, you're right in saying that if we want to reschedule, we need to make sure that everyone has a common time, and that might be a little bit tricky to do. Or anyone has any other suggestion that is better than the two that I suggest just now? Or you're just okay with anything, like with both?
Yeah, sir, for me, it's better if you just posted a video. We can
Right.
watch it.
All right. All right. You're attending the class from outside of the country, am I right?
No, I'm in Malaysia.
Oh,
Now.
right. You're in Malaysia, the other guy. Okay, I got
Sir,
mixed up.
I prefer to post a video because I'm not in Malaysia.
You're not in Malaysia, so you prefer to have a video.
Yes.
Yeah, just to make clear, even this video is right now being recorded. So video will be there, I think, regardless of whether I have this session or like I post other videos. Like, for example, I take other videos that are by other lecturers and I post it here. Or do you prefer like this video? So do let me know, maybe after the class or something, right? So for now, we are going to continue with our class. So far, last week we have covered a little bit on this topic. Let me just show you guys this. All right, so we have covered a little bit on number systems. So let me just recap a little bit. To those of you who are absent, do catch up with the lectures as soon as you can, okay? Because otherwise, you feel like it's going to get a little bit more tough if you don't do it as soon as possible. So just last week, we've covered about number systems. We talked about what is exactly a number system. It's very simple. Number system is like a language, but it's a language for computers, all right? And for number systems also, we actually have a few types of number systems that computer are using. So some of the common ones are here: decimal number system, we have a binary number system, we have octal and hexadecimal. All right, there are actually a lot more number systems outside there. If you're curious, you can just Google and you can just go and do your research on what are some other number systems that computers usually use. But in this course, we are going to deal primarily with this number system over here. It's the binary number system, right? Why is it binary? Because like it's the most fundamental number system that that can be used by computer. Actually, last week also we've learned that if you get a binary number, you can convert it to any number system, right? You can convert it to octal and convert it to hex and so on and so forth, right? That was what we did in the last class. So we covered this basic concept, how to write them. All right. Yes, these are bits. What are bits and what are nibbles? We also covered that. If you missed the lecture and you want to see what I'm scribbling, like do catch up with the recording. I believe they are there. If you're just viewing the slides, then there will not be any scribbling that I did in the class. All right. And we also learned how to count up actually. In decimal, this is how we count up. And we tried counting up from using octal. We tried counting up during using binary number system and hexadecimal number system as well. All right, and we also saw that this table, this is like a table that is very useful to show that the equivalent value, from various number systems, right? How do I get rid of this thing? Okay, so right? So this table shows equivalent value from different number system. For example, like over here, we have a value of 10 in decimal is equivalent to 12 in octal, and is equivalent to 1010 in binary, and is equivalent to 8 in hexadecimal. All right. So this table is very helpful. So I encourage that you guys try to learn this table. If you can, try to memorize this table a little bit, because it's going to help you with our upcoming lectures significantly. It's going to help you understand. It's going to help you grasp the concept very quickly if you know this table by heart. So I encourage you guys to go ahead and try to understand this, right? And also we tried our hands on base conversion last class. So I've shown you guys how do we convert numbers that are from one base to decimal number. Okay, so we tried binary to decimal, octal to decimal, and hex to decimal. And the trick is very easy, and we are using something we call the weighted sum. Okay, the weighted sum is something that you guys have learned, I think, in the past in your math or in your calculus, right? But it's nothing fancy. It's just adding the terms based on the weights, right? So if you're still not familiar with this, I highly encourage you guys go check out our class video because things are going to be more unfamiliar if you're not on the same page, right? So we tried binary to decimal as well, and we also tried something like this. So if you try to do this conversion on your calculator, we have point, you're not going to get any results. So if you have this, like you have to do the conversion by hand, actually, right? So I've shown you guys how we do that, and this is the answer in the slides. All right, and we've also tried something else, octal to decimal, and then we also try hex to decimal. All right, so now, so in today's class, we are going to continue from where we left off over there. Okay. All right. So we are going to continue from where we left off over there. So previously we were doing base 2, base 8, base 16 to decimal, right? Binary to decimal, octal to decimal, hexadecimal to decimal. Now we are going to go the other way around. It's the reverse right now. We are going to go from decimal to octal, decimal to binary, decimal to hex, and so on, right? So I'm going to show you guys. It's really simple how we do this. All right. So it involves 2 steps, and these 2 steps actually depends on what kind of a number you have. Okay. So these 2 steps are known as the integer part and the fractional part. Right. Let's see. So these 2 steps, I'll write this over here, integer part and fractional part over here as the method, depending on the type of number. You want to use one or the other, or you might want to use both. Okay, so using this method, what we can do is take decimal number and change it to any other base. Let's see how we do that. Okay, so let's talk about the first one first, the integer part. So the integer part is just a fancy name for long division. Sounds familiar? Rings any bell? Right, the long division. I think you guys had this long division, a lot of long divisions in your calculus, I think, previously, or at least in your linear algebra course. Right, so it's, as you can remember, it's very simple. So what if you have a number like this, 75, and now we want to convert this number to binary. So it's easy. All you need to do is long division, or the other name would be integer part. Okay, so let's just do this together. If you have a pen and paper, I highly encourage you guys take out your pen and paper and do this together with me, because otherwise you'll just be looking, and then like after this you're gonna forget. I 100% guarantee that. All right, take out your pen and paper and let's work this out together. And like you guys don't have to do it like after class. Okay, give me a second. I'm just gonna take out my calculator to confirm my answer later. Okay, all right, so now we are dealing with this number, and we have this number 75 in base 10. Now we want to know what is the answer in binary. Okay, decimal to binary. So what do? Yes, long division. So we are going to divide this number with the number, what do you guys think? The number 2. Okay, let's try the long division with number 2. Okay, that is how we do it, long division. So what 2 times what equals to 75? If you cannot get the exact one, you can get the closest one. Okay, so I'm going to say 2 times 3 is 6, and there's one remainder over here. And then like 2 times 7, it's 14. So what do I have as a remainder? I have 1 as the remainder. Okay, so far so good, right? So easy, right? And let's do this again. All right, so 2 times what equals to 37, or close to that. So I'm going to say here 2 times 1 is 2, but then I have a remainder over here. So 2 times 8 is 16. And then I have another 1 as the remainder. I'm just going to write that, the remainder. All right, and then I do this again. 2 times what equals to 18. So that's easy. 2 times 9 is 18. What do I have? I have 0 as the remainder. Okay, so far so good, right? You guys doing it with me? Yep. So 2 times what equals to 9? 2 times 4, that is 8. And now I have 1 as a remainder. And I'm going to do this again. 2 times what equals to 4? 2 times 2 is equal to 4. I have 0 remainder. And I'm going to do this again. 2 times what equals to 2? 2 times 1 is equal to 2. I have 0 remainder over here. Okay, now I can do this again. 2 times what equals to 1? 2 times 0. I cannot find anything. 2 times 0 is 0. And at the end of the day, we have a remainder of 1. Okay, so right now we arrive at this, and we cannot do any more long division over here because the bottom one is already a 0. So then what is the answer? The answer is very simple. The answer is you got to read this from the bottom up, that. Okay, so from here, you can see that the answer would be 1, 0, 0, 1, 0, 1, 1. Okay, so I've shown the answer on the slides. This is the answer if you read it from the bottom up. And one thing that you guys need to remember to do is to always put the base number. Okay, why do I say that? Because if you don't put this base number, this number can be anything else. It can be misinterpreted in other base. For example, you can write this in base 8. Possible? Yeah, it's possible. Number 1 and 0, they exist in base number 8, right? You can also it can also be interpreted like this if you don't write the base number. Okay, so one important thing to remember is always remember this base number. So if during those days when we had exams, I'm going to tell you guys a real situation here. When we had exams, students who don't put the base number, usually I will not give it a full mark to that because it is technically not a complete answer. So this guy is important, right? So any question on this? Clear? It's easy, right? No questions? Right. If you have questions, like feel free to put it in the chat. I am viewing the chat at all times. Okay. All right. So that is how we do decimal to binary. Okay. Long division. Right. Let's see what we have next. So what if you have this case? So you have a decimal number, and right now you want, instead of a binary, you want to put it, you want to convert it into an octal number. So what do? Again, we do long division, or the other name would be integer part, right? So let's do long division on this. So let's try this one. Okay, so we divide it with 2. Okay, so let's try that. Oh wait, is it 2? No, it's not 2. Why is it not 2? Because if you divide it by 2, you're going to change it into binary. Now, we are not interested in changing it to binary. We are interested in changing it to octal form, right? And for that, we need to divide it by, yes, you guessed it, by the number by base 8. Okay, so we are going to do that. Okay, 8. Okay, so 8 times what is 75? Okay, 8 times 9. 8 times 9. 8 times 9 is 72. So 72 and 75, we have a remainder of 3. Okay, cool, right? And we do it again. So 8 times what equals to 9? 8 times 1 is 8. Okay, so we can do that. 8 times 1 is 8. And then we have a remainder of 1, correct? And we do that again, like here. 8 times what equals to 1? And then there's no obvious answer over here. We can do 8 times 0, which is 0. And then the remainder over here is 1. Okay, and that brings us to the final answer of, if you read it this way, you would get 1, 1, 3. Okay, and that is the answer that we have over here, 1, 1, 3. And remember this, the base number, extremely important. Okay, so far, anyone has a problem? Okay, make sure you follow me, all right? Because like, think we are going to build this idea in our next slide. Okay, so if you're not clear, make sure you get clear first. All right. Okay, so now we are going to do the same thing with this one. So now this time we have a number, a decimal number, but instead of converting it to binary and octal, now this time we want to try something more challenging, that is hex. Okay, hex stands for hexadecimal. Okay, it's short form for hexadecimal. So hexadecimal means base 16. So in other words, this time we want this base 10 number to into base 16. Okay, we want to do that conversion. Okay, so as we did in the previous slide, we have been dividing it by 2 by 8. Now this time we are going to divide it by 16. Okay, I'm not so good with my math. I don't memorize the 16's multiplication table, so that's why I'm going to take out my little calculator over here to check what is 16 times something. Okay, so let's try this out. 16 times what equals to 75? Okay, let's try a guess. 16 times 5 is 80. 16 times 5 is 80. 80 is obviously more than this. We cannot do 16 times 5. Let's try 16 times 4. 16 times 4 is 64. Okay, 64. Okay, that is the best that we can go. That's the highest number we can go. Okay, we're going to say this. 16 times 4 is equal to 64. Okay, so 75 and 64, we do have a remainder of 11, correct? 64, yeah. Okay, 11 over there. Right, so let's try to do this again until we arrive at 0. So we do this again. 16 times what? You can get 4. Okay, 16 times 1 is already 16. Now the obvious answer is 16 times 0. 16 times 0 is 0, and the remainder you would have a 4 over here. Okay, all right, now comes the moment of truth. What is the final answer for this? So as we did in the previous slide, right, it's kind of obvious over here. Come on, like it's bottom up, you read this and the answer is 411. Is that right? No, it's not right. The answer is yes. Someone saying
the base 16.
Okay, base 16. Okay, someone said that. Okay, anyone else you think this is the right answer?
No, I think 11 changed to B.
Wow, wow, wow. Did you like saw my slides or something? All right, because that is the right answer, my friends. All right, see over here, the answer is 4B. Yes, we wrote like we read from the bottom up. However, bear in mind that we are changing into a hex number, and for a hex number, this guy has a value of B in hex. Okay, so that is how we arrive at this number. Okay, so how do I know that 11 is B? So that is why I talk about this table just now, remember? Remember this table? Right, so that is why like this table is extremely useful over here. If you know this table by heart, you can instantly know what is 11 in hexadecimal, okay? So I'm showing you guys here, okay? So 11 in decimal is B in hexadecimal. Okay, so if you know this table by heart, you're gonna instantly like that, like our friend over here, who got the answer, right? So you're gonna know that 11 is B, and then like 15. What's 15? 15 is F, right? So that is why I highly encourage you guys to like know this table by heart. It's gonna help you process things much more faster. Okay, right? But don't just memorize this table though. Try to understand what's going on behind, because when you understand, you don't even need to memorize a lot of it. Okay, it's actually quite simple. A lot of these numbers are like the same over here, right? Here and number up to 7, they are the same number, and even here, everything here is like the same thing, right? So do try to understand this table a little bit, and I assure you that you have an easier time down the course, right? Okay, so thank you very much for your response. I am really enjoying this so far. Okay, so this was how we arrived at this 4B, 11 over here, right? And so far we have seen how we convert a decimal number into 3 different base, binary, octal, and what is that? Hex, right? So now that is the integer part. Okay, that's the integer part. So let's go back to this diagram that I had over here. So that is the integer part. Okay. All right. Anyone wants to say anything? I like some kind of interaction. It's kind of boring, talking about. Okay. So that was the integer part. integer part. So now we are going to look at what in the world is this fractional part doing here, and in what kind of situation do we want to use this fractional part. So I'm going to show this right now. Let's go to our next example, fractional part. Okay, fractional part is this is the definition. It's so boring. I don't want to put everyone to sleep by just reading this. You can read this definition after the class by yourself. I'm going to show you guys what is going on and just how you do it. Okay, I think that's much more important than knowing what's the definition right now. Okay, of course, after this, you can take a look at definition and it will make much more sense when you already know the stuff. Right, take a look at this example here. We have this tricky number, 0.676875. Oh my God, like we cannot do like long division over there. It just doesn't work. Long division just doesn't work in this kind of case where we have this point, this dot over here. Okay, so this dot over here is also known as a fractional point. Okay, fractional point. All right, so let's see how we do this over here. All right, this is going to be a little different than long division, but it's kind of the same. Okay, so let me show you how. So the steps are easy. So just now we do division, right? If you want to change to binary, we divide by 2. So right now we want to still change to binary, still decimal to binary, but we have this trouble over here. There's this dot. So instead of doing division, now we want to do multiplication, right? Just remember this dot is a kind of troublesome guy. You cannot divide it, but you can multiply. So what do we do now? We want to take this number and multiply it. So I'm gonna just write this number down, 0.6875, and we want to multiply it by what? Exactly, by 2. Why 2? Because we are trying to convert it to binary. If you're trying to convert it to something else, to octal, you want to multiply it with 8, right? In this case, we multiply it by 2, and then let's find out what's the answer. I'm going to use my calculator on my phone. I have to be honest, I'm not good at my math, okay? Okay, let's try to do this one. 0.6875 times 2, what's that? Let me just, 0.6875 times 2. So on my calculator, I get this as my answer, 1.375. Okay, I hope you're also trying this yourself and you're getting the same answer as me. Sometimes, I have to be honest with you, sometimes I do make mistakes in a class, and if you guys are not doing this with me, we cannot catch the mistakes. So then it will cause more confusion down the line. So let's try to do this together. And if I have mistakes, like do catch me on those because like I might not realize it until the end, you know? Okay, so let's continue here. So now we have this. So what do we do next? So the thing that we're going to do next is we are going to take this part. Okay, oops, that's the answer. I'm going to show you how you get the answer, right? Okay, let me change my ink color so that it's easier to see. Now, we are just going to take this part over here. This part. This is also known as the fraction part. Okay, the fraction of this, and we're going to take just the fraction and multiply it by 2. Okay, so let's try to do that. Okay, let me change my ink again. Okay, so that means that we are going to have this 0.375. Now we are going to multiply it by 2. Okay, remember we are just taking the fraction, not taking the whole answer, right? This one over here is just not taken together. So now let's try this out on our calculator. What do we have? 0.375. Come on, anyone can be faster than me. My phone just locked itself. What is 0.375 times 2?
0.375.
Wait, what's the answer?
0.75.
0.75, right? That's because that's what I get on my.
Sorry, I said the wrong one.
Right, no problem. Right, I was a little bit shocked because it's different than what I get on my calculator. Checking my numbers here. Okay, I get 0.75. Okay, hopefully you guys get 2. Now, what's the next step? The next step is to take the fraction again and we multiply it by 2 again. Okay, so 0.75 and then you multiply it by 2. Okay, now this time we will get 1.5, right? Let me check my answer. 2, 1.5. Okay. So now, can we do that again? Yes, we can do that again. So we're going to take the fraction, which is 0.5 only, 0.5, and now we're going to multiply by 2, and we are going to get 1.0. Okay, now can we take the fraction again? Yes, we can take the fraction again. We can take like dot 0 over here and you multiply by 2, which you get 0 again. Okay, so I will just stop over here. Okay, right. So now what is the answer? So the answer is simple. So we are going to read this the other way around. Okay, just now we were reading this from the bottom up, right? Now this time we are going to read this from the top bottom. Okay, I'm gonna change this. So we are going to read this from top bottom like that, and the answer is here. Okay, not a very pretty drawing, but you get the point, right? So the answer is here. Reading from top to bottom, that will give us 1, 0, 1, 1. Remember, base number. Now the question is this the final answer? This is not the final answer because over here, remember, we have this dot over here. So in our final answer, we also will have this dot like that. So that is how I get my final answer on this slide. Okay, reminder to you guys, if you guys are viewing this slide only, you're not going to see what I'm scribbling over here. Okay, so yeah, if you want to see this scribble, it's only available in the recording. Right, I see some message over here. Anyone has any doubts first on this? Oh, okay. You guys are just writing the answer, right? Thank you very much for those who respond. Kumara, Shami, and Kumara again. Right? Thank you. Really appreciate that. Okay, so that is how we do the fractional part. Okay, so you have the integer part. If the number is a whole number without a decimal point. Now, if the number is like kind of strange like this, then we have the fractional part. Okay, so depending on the situation, you can choose which one to use, right? You can use the integer part only, or you can use the fractional part only. You can also use both. Okay, we'll cover that after this. In what kind of situation you want to use both. Okay, let's go to our next slide again over here. Okay, so right now we have decimal to octal. Okay, let's try this decimal to octal. It's going to be the same. So we have O.16. Now what we want to do is we want to multiply. Okay, so again, we are seeing that in this this example, we want to use the fractional part because this number here has this fraction point. Okay, so what we do is we start with this and we times with 2, right? Okay, not 2. Okay, this time we're going to times with 8. Okay, so 0.16 times 8, what do you get? So
1.28.
1.28. Okay, thank you very much. If you guys respond, then I don't have to keep unlocking my phone. 1.28. Everyone agree? Okay, thank you. Right, now we're going to take the same thing again. So this time we are going to take just a fraction, which is O.28. And we are going to times 8, right? Okay, come on. What's the answer?
2.24.
2.24.
All right, thank you very much. That is so much easier. 2.24. Okay, let's do this again. Now we have O.24, and we're going to do the same again. 8 times 8. Now what?
1.92.
1.12. Agree?
1.92.
1.92. Okay, thank you.
Yeah.
Now, can we do this again? Yes, we can do this again. Let's do this again. O.92 times 8. Okay, what's that? O.92 times 8.
7.36.
Okay, agree? Okay, right. Now, can we do this again? Yes, we can do this again. Like we can do this many times. Okay, for this particular number, you can do this many times, and you will never ever arrive at 0, just like the last example, right? So we need to stop at one point because we don't have all the time in the world to do all this fractional part, right? So I'm just going to stop it here. Usually I stop with the fourth, the fourth figure, okay, the fourth digit. So now let's stop this here. And what do we have? So we are going to read this top to bottom. Top to bottom, that will give us 1, 2, 1, 7, right? And base number 8. So what do we do next? We remember that this original number has a point. So we also got to have this point behind. Okay, 1, 2, 1, 7. Okay, so this is my answer, 1, 2, 1, 7. Like it can go on like forever over here, but for the sake of this class, we're just going to stop at this answer. Okay, so in your quizzes or in your questions that you encounter, I would be happy if you have like 4 digits after the point, right? You can give me more, no problem, but don't give me less because, right? It doesn't look very proper. Okay, 4 digits like after the point. Okay. All right. Any other questions on this? Still very straightforward, I believe. All right. Let's try our hands on something else. Let's try this one. Decimal to octal again. But this time, let's see what is the number. This is the number, guys. This is the number. How do we do that? Okay, remember just now we had an example with just the whole number without decimal point. And we had an example with just a fractional point without the whole number. And in this example, we have 2. We have the whole number, which is 75 over here. Okay, and we have the fractional point over here. So what do we do in this kind of situation? This is a situation where you want to use both. Okay, for the whole number 75, I believe we did this in this the example just now. So we did the integer part, and the answer we got was 113. Okay, now what about this fraction over here? So this we also did in just now in our example just now, and we get the answer of this. So at the end of the day, what's the final answer? The final answer is actually very simple. All you got to do is just combine the answers and you would get the final answer to be this. Okay, so it's just a combination of this and this. Okay, and you just do like that and that's your final answer. And remember, like there is this base. Okay, so you can apply this to any other number as well. Like if you have this weird looking number and you want to convert it to binary, you can do this same technique over here. You can, if you have a number and you want to make it into a hex number, you can still use this same technique over here. All right. Any other question like over here? Okay. So far it's good. I think if you have any question, do raise your hand. Do drop your question in the chat box. Right. Okay. So as a summary over here, what we have covered so far today. Yesterday, we did this part of the equation, not equation, but this part of the diagram. Okay, this part yesterday, and today we did this part over here. Okay, so yesterday we did binary to decimal, and now today, like we did a decimal back to binary. So now, this gives you an overall idea right now. So what you have right now is a tool in your hand to convert any number to any number. What do I mean by that, right? Any number to any number sounds so funny, right? For example, you have a number in binary. Now I want this binary number to be in hex. Can I do that? Yeah, of course. First step, you do this, right? You do the weighted sum, and then you get the decimal. After you get the decimal number, and then you do this integer or fractional part, and that's how you get the hex, right? You can do that, no problem. And same thing, if you have an octal number, now if you want this octal number to be in binary, you can do the same step. Okay, so from any number on the left over here, you can convert to any number here on the right. Okay, a little bit messy, but I think you get the idea. Now I'm going to show you a little trick over here that is going to simplify your life. Okay, now we are going to talk about this binary to octal, octal to binary, binary to hex, and hex to binary. If you haven't noticed, let me erase all this. Binary to octal, right? So binary to octal means you got to do one step over here, weighted sum, you get the decimal, and then you got to do another step over here, and then that's how you get the octal. Okay, vice versa. If you have, okay, so any number you got to do like 2 steps. There's like no other way around. But I'm going to show you here a quick little technique and I call this shortcuts because it's so easy to do. It allows you to convert this number in literally seconds. Like I guarantee less than 10 seconds, you can do it. Like if you're a pro, 3 seconds, you can get the conversion done. Okay, I'm going to show you this trick right now. Okay, so let's talk about this. Now you have this number, crazy number like this, and you have this binary, and now I tell you, you want to convert this to octal. Okay, so what are you going to do? Are you going to do binary to octal? So first you want to convert it to decimal, get the decimal. How do you do that? You do the weighted sum. That is one way to do it. And then after you get the decimal, you do the integer part, and then that's how you get the octal, right? Okay, so this method works. No problem with that. The problem is that you're going to spend some time. I think maybe 10 minutes to do the conversion. So why do things the hard way when you can do this conversion in 3 seconds? I'm going to show you 3 seconds, guys. Okay, let's see. All right, so I have this table over here, right? Looks familiar, right? This table, this was the table that I show in the just now, right? So this is just a table showing all these values over here in different base number, and then you have this equivalent value. So what you want to do when you have the large number like this and you want to convert it to octal, binary to octal, is first step, you want to divide the number. I call it this technique, divide and conquer. So divide the number. Divide the number in groups of 3. Okay, groups of 3. Okay, so why groups of 3? Because like binary and octal, so you get 2 to the power 3, you get 8. So this is the number that we have. Okay, groups of 3. So if you want to convert it to hex, that will be groups of 4. We'll take a look at after that. What if you have this hex? So for now, we want to convert to from binary to octal. So we divide this number with groups of 3. So this is how you do it. Now, once we get this group, it's easy. So now we take a look at this number over here, 101. What is 101 in, okay, 101 binary? What is it in octal? So I'm going to take a look at this table here. So 101 over here, binary, and I'm going to look at octal. What is the number equivalent value? The equal value in octal. The equal value in octal is 5. That is what I get over here, 5. This 3 numbers now becomes just 1. Okay. Okay, that. Now we are going to do the same thing for the next one. Okay, what is 011? And we want it in octal. So 011, 011, let's take a look at our table here. 011 is here, okay? 011, 11, same thing. Now, in octal, what do we have? We have this, okay? That is precisely what we have in octal. Okay, and now, final one. Okay, 111. 111 in octal is like 7, okay? So that is how I got my answer. The final answer is 735. Remember the base number. Okay, so how long that took you? I guarantee it's like for now maybe you took like 10 seconds or 15 seconds to do it, but imagine if you remember this table, it's going to take you 3 seconds or less. Okay, so 735 is the answer. Now if you take the other approach, that is the weighted sum and the integer part, fractional part, or whatever that is, you are going to arrive at the same answer. Okay, but this is much more, this is like a shortcut. Okay, so this is how we do shortcut conversion for binary to octal. Right, so far, anyone has questions? I see the chat lighting up. No, okay, not related. Right, okay, cool. Let's take a look at another one also. I'm going to talk about the limitation of this method later. Okay. So now we want binary to octal, and okay, let's try this another example, right? So now we have another example. It's still binary to octal. Now this time it's a little bit tricky. So let's try our best at our divide and conquer strategy. So first thing, we want to divide in groups of 3. Groups of 3 because it's binary to octal. Okay, so I'm going to do this line over here. Groups of 3. Over here again, groups of 3. And over here again, groups of 3. Okay, but this guy sadly over here doesn't have groups of 3. Or should we do this the other way around, right? Okay, let me do this the other way around. Let me do this like this way. Groups of 3 and groups of 3 and groups of 3. Hey, this guy, like if I do that, this guy over here, this still doesn't have groups of 3 anymore. Okay, so how do we go about in this kind of cases where the digits they don't divide up like nicely in the groups of 3? So the answer is actually quite simple. Okay, now when you divide with groups of 3, now you want to start at this point here. You want to start at the right instead of starting from the left. Okay, I'll show you why. So let's do that. We divided this into groups of 3. Groups of 3 over here, groups of 3 over here, and groups of 3 over here. So the reason why we can divide this groups of 3, and then to make this groups of 3 again, what we can do is we can just add 2 zeros in front. Can I do that? Can I add 2 zeros in front? Does it change anything about my number? Okay, if I have the number 100, if I add 1 0 in front, does that change the value of the number? It's still 100. Right? If I add like many zeros, does that change the value of my number? It does not change the value of my number. So I can add the zeros in front like this so that I can make it into a groups of 3. Okay, so clear, right? Now, once you have this in groups of 3, now it's again divide and conquer strategy. Okay, so 101, what's 101? 101 is 5. Okay, so what's 011? 011? 011 is 3. Okay, what's 111? It's 7. What's 001? That's 1. Okay, so that is how easy it is to do this kind of conversion. Okay, so how long did that took? I bet it's less than 5 seconds at least. Okay, and remember one thing, I didn't put in the slides, but base number. Okay, right. So far so good. This is to show you guys how do we tackle situations in which the number don't divide nicely. Okay, right. Let's move on. Wow, so quick. It's like 15 minutes already. Okay. Now we are going to see yet another example. I'm still going to stick to this example, binary to octal, so that this one sticks with you. Right. Now this time, this tricky number over here. So what's different from the past examples? Now we have this annoying little thing over here. Every time that we have this annoying thing, like it gives us more work, right? Okay, but not for this, not for this, I promise. Because this shortcut method is also going to work if you have this little annoying dot over here. Okay, now let's see. So from previous example, I show you guys, okay, so you want to start grouping from this from the right, right? So over here, what I'm going to do, let's start grouping, right? This and this and this, and okay, I'm going to add this 1 0 here. Now, can I do that? No, I cannot do that. Okay, because the number over here after this point and before this point, they are not the same. Okay, they're not the same. So over here, the number over here is 10 times smaller than the number over here. Okay, because that's dot. So because of this difference, now we want to start grouping now from this dot over here. Okay, we'll start grouping from this dot over here. So let's make a clear demarcation over here. Now let's start grouping from there. Okay, so what we're going to do is again this group, and this group. Okay, and obviously we have this group as well. Now that leaves this one also. Now we can do the same trick. Can I add 0 over here? Yes, I can add 0 because it doesn't change the thing about my value. Okay, if I have 75.1 and I add a 0 behind that, so does that change my value? It's still 75.1. It doesn't change. It doesn't change this value of 75.1, no matter how many zeros I add after this point over here. So now in the same situation, in the same scenario also here, we have, now we can add zeros over here just to make the group of 3 complete. So what do we have over here? So 110, so 110 is 6, 101, 101 is 5, 011, that's 3, 111, that's 7. Okay, and now the final answer would be, let me just write this down, 735 dot. Okay, remember this dot 6. And what do we have? Oops, sorry. I have the base number. That is the base. That's base 8. Okay, that is how I get this. Is anyone confused? So far, so good. Okay, so that is how we tackle this when we have this decimal point. So now you see that we can add zeros actually at appropriate places. So in cases like this, we can add zeros after this dot over here. And if you can also add zeros like at the front over here, because in those cases, it doesn't change the value. All right. Okay, now let's take a look at the next example. Now I'm going to go quickly over here because you already got the idea, right? So now we are changing the situation a little bit. Now we have this hex, okay, hex. So I want binary to hex. So just as I have shown you just now, binary to octal, groups of 3, binary to hex, groups of 4. Okay, so I'm going to take my table again, and I'm going to make everything into groups of 4. Okay, so over here I have groups of 4. Now I'm going to see what's 1101 in hex. So 1101, 1101. Okay, 1101 is that, and I have D. What is 1101 again? Okay, same thing. I have D again. What is 0001? 0001 is just 1 in hex. Okay, and don't forget this base number 16. Okay, now
sir,
yes,
I have a question.
go ahead.
Okay, why don't you divide it into a group of 3 instead you do it into group of 4?
Okay. Well, if I divide this into a group of 3, I would be making the conversion into octal. Okay, get what's going on over here. I am making this conversion into not octal. I want the final answer to be in hex. That's why this time it's group of 4.
Okay. So if it's hex, we have to divide it by a group of 4.
Correct. Okay. Why is it groups of 4? Okay, remember the thing that I showed you just now. Okay, 2 to the power 3, you get 8, right? Now we get 2 to the power 4, you get 16. So because of this, we want to divide it in this groups based on this. Okay, 2 to the power 3 and 2 to the power 4. Okay, so hopefully that makes it clear. Anyone else have any question? Like, good question, by the way. Maybe some of you have the same question, but you dare not, ask me like that. Okay. Thank you very much for asking this question. Yeah. Any other issues with this? Now, can you do this conversion like this? Let's say I give you a fancy number. Dot. Okay, dot over here. Okay, this is a 1. Okay, now can you do this conversion over here? Yes, you can use the same principle and convert this kind of odd looking number into base 16. Okay, divide and conquer as usual. Now make sure you guys make sure you guys take note of this 1011 over here, and you guys make sure that you guys complete the groups by adding zeros at appropriate places. Okay, so that's a little hint. It might be in our next class quiz. All right, so do make yourself familiar with this kind of conversion. Any question so far? We have just hit the 1 hour mark of our class today. So far, so good?
So far, so good.
Yes, sir.
Okay. All right. So as I promised you in the beginning, right, I am, if possible, I don't want to make my classes very long because I think there is a limit to everyone's, capacity to take in new things. And I understand that. I was also a student before, and long classes just makes it less and less productive. So what I am going to do right now is I'm going to release to you yet another quiz, and the quiz is going to cover, yes, number conversions. Okay, so I'm going to release this quiz like immediately after we end this call, and I'm going to talk about a quiz a little bit right now also. So to those of you who attempted the quiz, our last quiz was quiz 1.1, right? So if you haven't noticed, the quiz has got a deadline of 1 day. Okay, So I decided to give you a generous deadline of 1 day because I realized that some of you might not be attending the class in the country. So some of you might be attending the class in a different time zone. So considering that fact, then I am giving you 1 day to complete the quiz. Any quiz from this point on, 1 day is the time limit. Okay, so the thing is, what happens after you submit? Like you submit after the 1 day. What happens like after 1 day? Do I still open the submission? Yes, the submission will still be open. Okay, and I'm going to keep the submission open until the end of the semester actually. And so what's the difference if you submit within 1 day and you submit after the 1 day? There is difference, and the difference is that after you submit the 1 day, I'm going to get a notification saying that this is a late submission. So a late submission is not good, right? Not good. Why? Because everyone else in the class obeys, not obeys, I don't want to say that word, it's not so good. Like everyone in the class follows this 1 day submission, right? So if anyone doesn't follow this submission, if it just doesn't make it fair to everyone else who obey, right? Does that make sense? Okay, so that is why if you submit after 1 day, I will still accept your submission. No problem with that, no issues. But you would get a late submission penalty. Okay, late submission penalty. So just take note on that so that you're aware of the deadline, so that everyone else who follows that is treated fairly. Okay, so I want to make sure that everyone in my class gets a fair treatment, especially when it comes to deadlines. So I hope this makes sense. Okay, but since I did not mention this in the past quiz, so for the first quiz ever, I am just going to omit the late submission. So even though if you submit late, I am not going to count that as late because I did not inform you guys in the class. So it's not a fair thing to say it right now. Okay, so first quiz, it's okay. I will not consider late submission, but your marks are still there. From this quiz onwards, I will monitor who submits on time and who does not submit on time. Okay, just to be fair to everyone. Can we agree on that?
Yes, sir.
Okay.
Yes, sir.
All right. So thank you very much for your response also. Okay. So the other thing that I would like to do right now is I want to briefly go through our quiz in the last class so that you guys know where are your mistakes. Okay. So I got this feedback actually from my last semester session. They really wish that I discuss the quiz. So I'm going to do this this semester. So your feedbacks actually do matter. It helps me to improve my teaching, helps me to also improve my classes in the future. Okay. So I'm going to turn this sharing off and I'm going to share this quiz. Okay, let me open this quiz page. Come on. Okay. Okay, so over here, you guys are seeing the quiz page, right? Okay. So this quiz, we were talking about analog and digital signal. So if you guys got this right, congratulations. You guys got it. You guys understood the things that I talked about in class. But if you didn't get this all this question right, it's okay. It's a learning process, and there's no wrong in making mistakes. Everyone makes mistakes. You just got to learn from that mistake. Okay. So over here, I'm just going to go through very, very quickly in less than 5 minutes, maybe, on what's all this. Okay. First question: digital signal offers better clarity, but analog signal offer better quality. So what was the answer? Anyone got it? Anyone? You got it right? What do you think?
Wrong.
What was your answer? Okay. You got it wrong? What was your answer? True or false?
I think I said true.
Okay, actually this question is, I think, a little bit not very clear. Okay, so analog signals, if you take a look at analog signals, so imagine analog radio. Analog radio is the kind of radio that you have in your car. So if you turn on the radio, what do you notice? You notice like there's this noise, there's this sound, like the static noise, right? And you kind of have to tune like the antenna to get a better quality. Okay, so I think the answer over here can be it actually depends. But the answer that I provided over here is analog signal. Usually they offer not so clear. The quality is not so clear. Why? Because analog signal can degrade. Okay, but the digital signal does not degrade, so it is clearer than the analog signal. Okay, so digital signal offers better clarity, and that's true. Analog signal offers better quality, so the answer should be false. Am I right? Anyone else who got this right?
So
Yeah.
I answer false, but the answer is true.
True. Okay.
I mean I got it wrong, but I answer false.
Okay. Okay. So I think this question is a little bit ambiguous. So it can be false, like the one that I say, the explanation that I said just now, but it can also be true. So in a true situation, it means that the analog signal actually offers you better quality. Okay, you can think about me speaking to you like face to face. The quality of my voice is so much better when I'm speaking you face to face in an analog form than digital form. Okay, so I think I'm gonna accept both answer on this question. Okay, so that's why we are discussing here right now. Okay. All right, so this image over here shows an example plot of a digital signal. So over here we are seeing this analog signal. Over here, digital signal typically don't look like this. Okay, so the answer will be digital signal. So this one will be false. All right. So one big advantage of using digital signal is that the record can be preserved over time. Is that true or false? So as I said, like in digital signal is not subject to degradation over time. Meaning to say, you can just copy the same digital values over and over again without affecting the quality. Okay, think about it like your assignments, right? You can copy your assignments for 100 times, 1,000 times, a million times. Your assignment will still stay the same. It will not change in any way. Okay, that's because the assignment is in a digital form. Okay, you can clone my voice in digital form, and then you can copy it again and again and again, and then the voice will still be the same. So if you to try to do this with the analog signal, like if you have like a cassette tape, if you were to take the cassette tape and copy it to another cassette tape, if you do this a number of times, like the more you copy, actually the more you would see that the quality degrades. Okay, another example would be to photocopy, right? If you photocopy a document, right, again and again and again and again, right, every time you photocopy, the quality kind of drops a little bit. If you do this for 1,000 times, you can barely see what is on the document anymore. Okay, so hopefully that makes sense. That is the advantage of using digital signal. All right, over analog signal, so it can be preserved over time. Yeah, that's true. So this image here shows here an analog device. Okay, maybe some of you were confused. Like this is the CD that we have. There's a modern CD. So there's also another type of the big round dish that you have during those days. Maybe I think some of you got this wrong because you thought, oh, that was that dish. I'm not sure. I forgot the term. What's the name of that thing? Like, but it looks like this CD also, but it's quite large, and you got to put it on like a player and like with a needle, and then you can play it. So that one is analog, but this CD is a digital device. Okay, so yeah, the final two question is an open-ended question. So I will evaluate your answers based on what you put in here. Okay, so if you put in anything that is on my slides, you'll be right. And if you put in anything that's not on the slide, I also evaluate them. And actually, I really like it when you take things that's not in my slide. So please feel free to go out. Knowledge is out there. Take whatever you learn outside and put it in here. So I really highly encourage you guys to do that. I think in my next quiz, I'm going to restrict this answer, saying that, okay, please do not put answers that are on my slides already, okay? Because that's kind of like copy and pasting. So I don't want you guys to do that because I want you guys to learn even more. Okay, so this one is kind of subjective. It depends on your answer. All right, any question on this quiz? Is there anything that is not clear except for this first question over here? It can be a little bit ambiguous depending on the situation. Anyone? And I'm not sure if you guys can check your grades. In my account, I can see everyone's grades over here as long as you have already submitted. And yeah, I think you guys can see your own grade, or maybe I'm not sure. All right, so do let me know if you have any question. Your carry marks and everything, it will be like right here. So again, so you guys can see like in real time, okay, how are you doing, like, and what do you need to do to score even more. Okay. All right. So if there is no question, okay, as I said just now in the beginning, we don't have class on this Thursday because we're having a public holiday over here. And in place of that, I will post a video, and I really hope you guys will watch that video. If you guys have any questions, please feel free to drop comments, or please do message me. And in the next class, we will discuss about what's in the video, and potentially we'll also have a quiz. Okay, so do watch the videos that I am posting, because that's not additional stuff. That is the stuff that I want everyone to watch, okay, for every single class, because that is going to help you understand the concept even more. All right, that is all for today's class, everybody. And after this, I'm going to release the next quiz. And this time, the submission requires you to take a photo. Okay, so this photo will show me actually what are the workings of your workings in getting the final answer. So I would like to see that in your quiz answer, and I will evaluate the answer based on the workings. So in any conversion, it's going to be about base conversion, by the way. In any conversion that you do, so make sure you show all the workings so that I can evaluate your workings as well. Okay, don't just give me a final answer there and I'm just going to think, oh, okay, where do you get this final answer from? So do write whatever workings, just do take a good picture of it. Okay. And yeah, questions?
Do I have to convert the photo or just snap it?
Sorry, I wasn't very clear on my side.
Do I have to scan the photo and convert into PDF, or just snap the photo?
Okay, good question. Thank you. So the submission will accept multiple types of file. You can submit PDF, you can submit image file. Okay, but I will highly recommend that you use a phone scanner app. Okay, you guys familiar with the phone scanner app? It allows you to take like a photo, and then like it converts the photo into like a PDF or something, or into a better image, so that what you write is clearer. Okay, so I will post in the chat room or in the channel later on what are the apps that I recommend for you to use as a submission. Okay, because last semester I did also I didn't tell everyone to use this app, but at the end of the day, some of the pictures are very blurred that I could not evaluate that answer very well. So it would be kind of a a waste, because the answer wasn't clear, and then you got penalized because of that. So I definitely don't want that to happen to everyone, and I highly recommend you guys use the phone scanner app. There are many out there. I will post some of my suggestions in the channel. Okay, thank you for the question. Any other question?
You'll be posting the video on Teams, is it?
Yes, in the channel. Topic
Okay.
2, topic 2 channel. So I'll be using Teams for this semester. At the moment, I am still exploring our new platform, Brighton. I would not want to, like change the platform all of a sudden half semester. Then everyone will be like in havoc. Okay, is it this or that? Is it this or that? So I think a better way would be we're using Teams most of the time, but I'll also upload some materials over there on Brighton, if you're looking for this course on Brighton. Okay.
So the quiz we can do until this whole day, right? So,
Yes, I will give you one day
okay.
to accomplish. Right?
Okay.
Okay. Any other question? Okay. If you have no questions, thank you very much for attending our class today. and I will see you again next class. If you do have any questions, please feel free to stay back. I will be staying back to answer your questions as well. All right, guys, take care, and I'll see you soon. Bye-bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.